Right. Okay. So we're doing day 2 of the how much acid is in your drink, and so what I've got is 25 milliliters of cranberry juice, and so the procedure here is I'm going to take 25 mils of cranberry juice. I'm going to dilute it by 50%. So I'm going to, just to make it kind of show up. So I'm going to add another 25 milliliters of my distilled water to this juice here. So I'm up to 50 mils total, but still 25 milliliters of the juice. And we're going to use this to kind of find out what the concentration is of acid based on our titration curve. So what I'm going to do is we have pH probe here. I'm going to add my juice to my solution here, and then I'm going to drop my pH probe into the solution, and we're going to take a reading every milliliter of the pH. Now, the pH is going to change over time, so you're going to have to, I'm going to call like 1 milliliter, and you're going to have to look at the pH meter and just write down exactly what it says. If it varies and changes a little bit, it's okay, because we're going to take so many readings it'll kind of blend out once we graph it. So we'll let it go ahead and stabilize at our starting point, which will be, of course, at 0 milliliters. And then we'll take several readings over the course of this experiment. So once it's pretty stable. I don't know, it's not quite stabilized yet. So this would be the initial pH reading for cranberry juice. And like I said, it's going to vary a little bit back and forth as it's, stirs and gets through it. But we'll call them, and you guys need to write down each milliliter until I stop. And I'm guessing that we'll probably get through 40 milliliters as this goes. So let's go ahead and get started. We'll say our starting point is right now at 2 point, I don't know, you decide, 2.95 sounds good. So I'm going to add 1 milliliter and tell you now 1 milliliter is added. So you'll write that down as 1 milliliter reading. Now I'm going to add a second milliliter. Now the second milliliter is added. Go ahead and write down what you read. And I'm adding our base, 1 milliliter at a time. So now I'm adding the third milliliter is added. Write that down for your third milliliter reading. Now write that down for 4. That's your fourth mill. Now that's your fifth milliliter, so we're on 5. That is 6 milliliters. That is now 7 milliliters. This is now 8 milliliters. This is now 9 milliliters. This is now 10 milliliters. This is 11 milliliters, so write that down as your 11 milliliter reading. Now we're at 12 milliliters. We're at 13 milliliters. You notice there's not a whole lot of change yet, but it's coming. Now we're at 14 milliliters. Write that down. We're at 15 milliliters now. You can write that down. Now we're at 16 milliliters. That is 17 milliliters. 18 milliliters. 19 milliliters. 20 milliliters. 21 milliliters. 22 milliliters. 23 milliliters. 24 milliliters. 25 milliliters. Should be a drastic change soon. 26 milliliters. 27 milliliters. 28 milliliters. 29 milliliters. 30 milliliters. 31 milliliters. 32 milliliters. 33 milliliters. 34 milliliters. I know it's boring. 35 milliliters. 36 milliliters. 37 milliliters. 38 milliliters. We should start to see it level off again. 39 milliliters. 40 milliliters. 41 milliliters. We'll go to 45. 42 milliliters is there. 43 milliliters is there. 44 milliliters. We'll do one more. And finally 45 milliliters. So write that down as your final reading. So take a look at the juice now. I know you guys didn't get to see it, but as it went through the equivalence point, the color of the cranberry juice goes from like a really pretty red to this disgusting vomit orange or green kind of look to it. So what I would like to do now, probably didn't anticipate that I would do this, but what I'd like to do is I'm going to go ahead and do a second video separately where I just kind of let you see what happens over the titration in time so that you can see what you did not see happening over here while you were writing down all that data. But you guys are going to use that data, graph each milliliter that you added versus the pH, and it's going to give you a nice smooth curve, and you need to label your equivalence point on that curve. Okay, so I'll do one last video after this kind of demonstrating what you saw here, but we'll go through it a little bit more quickly.